but they failed to cope with the speed at which the hyacinth colony doubles itself. So each of the three methods have been ineffective, expensive, and infeasible. So the proposed solution basically lies on the early detection of the plant, followed by an action resulting in an effective control. So, being inspired by the extensive success of aerial vehicles in the area surveillance applications, the main aim of this work has been to design and simulate a quadrotor UAV, which is specifically suited to the detection of the hyacinth plant. Along with achieving this main objective, modeling of the quadrotor UAV and designing an adaptive controller for stabilizing the quadrotor at times of navigation, and building an image recognition model had served as the specific objectives. So I'll move on to the design procedures followed to meet the objectives I mentioned. Towards achieving the objectives, modeling of the plant had served as the first step. So dealing with the navigating quadrotor, describing its orientation and position in terms of a stationary reference frame is the first step. So in this paper, a singularity-free representation of orientations has been used
Yeah, we couldn't
by using.
hear what you are saying. I don't know what happened, Merit.
Okay,
Why
maybe
you
my
don't
mic is not
clearly
working.
articulate what you speak?
I am speaking clearly, sir. Maybe my mic is not working well.
Continue. Continue.
Okay. So the next step was to distinguish the forces and moments that act on a flying quadrotor in each of the three translational dimensions. Then the need forces and moments are presented here. Then the laws of conservation of linear and angular momentum has been applied to reach out a set of equations, which basically describe the kinematics and dynamics of the system. So the overall flight dynamical model is presented here, which presents how the states of the quadrotor evolve over time. So having the dynamic system modeled, the problem of stabilization arises, and it's basically dealt with controller design. So for the chosen application, we know that the chosen application requires an outdoor flight, which is characterized by diverse phenomena conditions. So the controller chosen for this specific type of application is the model reference adaptive controller, which is able to put up with unexpected disturbances and uncertain scenarios. This controller tries to drive an undesirable response of a plant to converge to the response of a pre-encoded reference model. So the approach followed is named as adaptive augmentation, which consists of two separate controllers. A baseline controller, which tries to ensure tracking and stabilization when operating conditions are nominal and expected, and an adaptive controller, which guides the baseline controller to ensure stabilization when conditions are unfavorable. So this separate type of design enables computational ease and efficiency by letting the adaptation scheme to only emerge when needed. So the baseline controller is constructed as two cascaded controllers emanating from the translational and rotational dynamics of the quadrotor. So the design follows by defining a positive definite Lyapunov function for both the position and attitude control loop. In both the position and attitude control loops are defined in a way that the derivative of the defined Lyapunov functions becomes negative semi-definite. So the ones presented in red are the baseline control loops, and this summarizes the baseline controller design steps. So the adaptive controller design basically starts with reference model construction and then It designs two control loops for the altitude adaptation and attitude adaptation. So the reference model construct is designed to decode the desired plant response. It consists of the developed nonlinear model of the quadrotor, which is assumed to be operating in ideal operating conditions and which is controlled by the baseline control laws which are developed earlier. So the overall closed loop system is guaranteed to be stable in nominal scenarios. So the fact that the reference model is nonlinear enables it to decode complex nonlinear behaviors the actual plant might exhibit. So the adaptive altitude loop is then built as a direct adaptive control scheme, which makes use of the modified MIT rule, and then it's done by defining a parameter called theta, which acts as a variable gain, so that the developed baseline controller varies in terms of variable environments. Then the parameter adaptation law we see here is then defined so that the defined cost function converges to zero. The adaptive attitude controller is then set up as an indirect adaptive controller, which is based on a linear time variant angular dynamical model. So looking at the rotational dynamics presented here, we can see that the quaternion rate dynamics is free from any uncertainties, but the angular aerodynamics suffers from three main types of uncertainties, which are caused from unknown disturbances, inertial parameters, and aerodynamic coefficients. So the body rate dynamics is reformulated in this way, and then a positive definite Lyapunov function is then defined, and then the standard parameter update laws of body reference adaptive controllers is adopted so that the derivative of the defined Lyapunov function becomes negative semi-definite. So using this parameter laws, the adaptive control laws are designed, and this summarizes the adaptive controller design states. So I'll then move to the development of image recognition model development for the detection of the high-sense plants. So there appears to be no pre-prepared dataset of images for the image recognition problem. So the problem formulation starts with defining two other plants called water primrose and pennywort, which do have structural and habitat similarity with water hyacinths. And it's worth mentioning that the internet has been the only available source for dataset preparation. So out of 4,000 images collected from the internet, 3,200 images were allocated for training, 400 images were left for the validation set, and the rest 400 images were used as testing images. So the data set is pretty scarce considering the data intensive property of neural networks. So in order to come across this limitation, the technique of transfer learning has been applied using the process of fine tuning. So a pre-trained model named as BGG16 has been adopted. This network comprises of 16 convolutional pooling layers, and it's a trained model which is based on the ImageNet dataset, which comprises of over 1 million images. The accuracy it has attained.
Merit, you have only 1 minute left.
Okay. So the accuracy levels we see here were obtained for the training, validation, and testing sets. Further analysis have also been done to calculate the 4x4 conversion matrix and precision equivalent F1 score for the trained model. So to assess the tracking performance of both the baseline and adaptive controllers, different simulation tests have been done. So the first tracking test that has been implemented is the bow-tie trajectory tracking test, which basically presents a complex trajectory for a dynamic system to follow. The main purpose here is to show the effectiveness of the baseline controller to take the quadrotor to a target position from its initial position. So as seen from the plot here, it can be seen that the baseline controller is able to maintain tracking and stability with the control energy demanded from the actuators presented here, which present a variable, feasible, and smooth control loop. Another case has been performed to test the disturbance rejection capacity. This test has been performed on the switch trajectory, which is a typical type of area coverage trajectory. A disturbed environment with counteracting roll and pitch movement and a counteracting longitudinal disturbance has been applied. And it can be seen from the proof that the fixed gains of the nominal controller fail to ensure stabilization and um, drive the system to instability, while the adaptive augmentation, which is presented by the float inlet, has maintained tracking and has maintained stability of the dynamic trends. Another has also been implemented to test the uncertainty tolerance ability of the designed controller. It was tested by using 5 times the parameter values that has been used in the nominal design, and the proof here again shows that the adaptive augmentation is able to maintain tracking and stability with the control rules that are presented here. The performance has been further analyzed by using the integral time absolute error, and it can be seen from the nominal system behavior that the baseline control rules fail to stabilize in terms of disturbance rejection and parameter uncertainty tolerance. But the adaptive controller has maintained new design time performance even though these parameters were imposed. So putting in a concluding remark, an adaptive controller has been designed and tests has been performed where successful rejection of uncertain conditions, including disturbance and parameter uncertainties, has been observed. Additionally, an image recognition model has been developed and these accuracy levels have been gained. This work can further be developed by using a fast learner algorithm and by considering the concept of persistence of excitation to ensure parameter estimation convergence. And the image recognition model can also be reformulated as an object detection model to improve um, the application areas. So I do thank you for your attention.
Okay, thank you, Marat, for your presentation. So it is difficult to listen to what you say because of your very low voice for presenting your work. Saying this, I can give a chance to the audience to raise questions and give you suggestions. The floor is open now. Any question or comment or suggestion? So, Merit, can I ask you one question? Merit,
Yes,
so can you tell us your key finding? What is the finding and your contribution doing this research?
so my contribution regarding the controller development,
Afishinization
uh,
limitario. Please
I'm
correct
speaking
your
clearly.
mistake. I'm telling you repeatedly why you repeat the same. Mm, hello?
My contribution regard, yes, I'm speaking.
Okay. So tell us.
So regarding controller development, adaptive control mechanisms have been developed and uncertainty conditions, which are 5 times the design performance were imposed, but tracking has been maintained by using the adaptive controllers designed in this paper.
Can you activate the video? Can you activate the video, please? Video mode of your presentation. Okay.
Yes.
Let me, if that improves your performance of speech. Mm-hmm.
So regarding controller development, the adaptive controllers which have been developed in the paper has maintained tracking performance even though the seven conditions have been imposed. And uncertainties which are input type uncertainties and also parametric uncertainties have been imposed into the system, but the developed controllers have maintained tracking and stability.
When will you make it practical? Do you have
I
a plan
need
for
to
practical application?
I do have a plan. I have not started yet, but it's one of my future works.
Yeah, okay. No, all right. Thank you so much for your presentation and the feedback you've been for reflecting on the questions I raised. Okay, then with this we conclude the presentation of Niheret in this afternoon, and then we'll proceed with another presentation. The next presenter is Joshua Atish from UN African Regional Center for Space Science and Technology Education. His title is Global Warming in Ghana's Major Cities based on statistical analysis of NASA's prediction of worldwide energy resources over 3 decades. So, is Joshua with us? Yes, Joshua. And if he is not present, then we expect the video, pre-recorded video from the organizer's side.
Unfortunately, he did not provide a critical video.
Really?
Yeah.
And then we will proceed to another presenter. Is that okay?
Yeah, absolutely.
Okay. So now, is there Mulukan? Mulukan Manevo
Okay, I'm here.
from, okay.
Okay.
So,
So
let me
let me
introduce
introduce
Mulukan.
Mulukan.
Mulukan
Mulukan
Manevo is
Manevo
from Addis
is from Addis
Ababa
Ababa
Institute of
Institute of
Technology.
Technology.
His title
His
is
title is
Network Model Based Model Reference Adaptive Control of Quattro Tor UAV for Precision Agriculture. And Mulukan, you have 15 minutes. You can continue your presentation by sharing the presentation slide.
Okay.
Mulukan, 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 why don't you speak? Your mic is active. I see you. You are online.
I need to be moderate on the data. Okay, okay, Doctor. Can I
Please
start?
share the
Please share
presentation and
the
speak.
presentation and
Start.
speak. I share, Doctor.
No, there is
No,
no
no, there is no
presentation on
presentation
your side.
on your side.
So if you have
So if you have,
trouble
Yeah,
to
please.
yeah,
Let me
please
advise
let
you
me advise you
share the screen
share
and
the screen
open
and
your
open your
presentation from the
presentation
screen
from the
and
screen
make it
and
in
make it on
slideshow.
slideshow. Okay. Borrow no, Doctor.
Good.
Is it
Very
visible now?
good.
Very
It is
good. Okay. It
visible.
is
You can
visible. You can
continue. You have
continue.
15
You have
minutes.
15 minutes. Okay. Okay. Good afternoon, everyone. My name is Muluka Manego. Here I'm going to present neural network-based model reference adaptive control for parotid UAV. Here there are what I'm going to present in this conference. On the first part, we will see what is precision agriculture and how it is important for our farmer and how we can integrate among the aerial vehicle with machine learning approach for precision agriculture. Finally, based on the simulation discussion, we can make some conclusion remarks. So to start my presentation, let's start with the background of the study. Agriculture is one of the basic needs for the continued existence of human life because it is directly related with food production. Currently, the world population is exponential increase. This calls for rapid increase in food production by applying currently available technology that maximizes production with a minimum cost of input. This helps farmers to precisely determine what inputs to put, exactly where and in what quantity. In a sense, when we see or when we say precisely controlling the crop is a broad concept. For this reason, in this research study, we only focused on detecting the yellow rust in the crop. Yellow rust is highly destructive fungal disease and it has the potential to damage 50 up to 100% of a crop if it is not controlled and prevented at early stage. So this study quadrilateral wave is applied for image acquisition and deep learning for image analysis. This helps farmer to determine and to take control action early before this wheat rust cause a huge damage in the crop. As you can see from the figure, this is overview of our research study. This is the wheat crop. This is a desired trajectory that we're going to implement on the autopilot drone. By following this trajectory, the quadrotor take image from the crop. By obtaining image, we have here the pre-trained model. So the image passes through this model. Finally, we can determine the severity level of yellow wheat stress in the image datasets. As a control researcher, our primary goal of this research study is developing high performance quadrilateral control algorithm for quadrilateral weaving. In control system, there are two types of uncertainty. Those are matched and unmatched uncertainty. Matched uncertainty is like parameter variation or disturbance that included in controller design process. So controller has knowledge about this type of uncertainty. In another way, or in the case of unmatched uncertainty, they are not included in controller design, this much uncertainty. So the controller does not have knowledge about this uncertainty. So the currently existing controllers has a promising result when the system is affected by much uncertainty. Whenever the system is affected by much uncertainty, these existing controllers lose their performances. For this reason, we are designing intelligent controller by utilizing the adaptive or the learning capability of neural network. These intelligent controllers shows a promising result when the system is affected by matched or unmatched uncertainty, right? So these are the main contributions of our research study. The first contribution is developing more precise quaternion-based mathematical model of quadrilateral flight dynamics. In control engineering arena, when the precision of model is increased, this increases the performance of the controller. Right? For this reason, by including every effect which has a significant effect on the quadrilateral dynamics, we model more precise quadrilateral dynamics. The second contribution is implementation of artificial neural network based novel intelligent control approach for quad water. This approach is a novel approach to the base knowledge of orators. The third contribution is implementation of online learning algorithm to enhance controller performance. In this case, or in our study, online learning algorithm enhance controller performance. We will see later on the result part. The first contribution is proposing and simulating efficient data acquisition and analysis mechanism for precision agriculture. When we go to the methodology part, the first part is controller design part. To design controller, we first model the physical system. Modeling means it is expressing a physical system in terms of mathematical equation. So to model quadrature dynamics, we have to first define coordinate frames in quadrature system. In quadrature system, there are two coordinate frames, right? Those are body frame and inertial frame. The reason why we define these frames are because some built-in sensors measure their quantity based on their respective reference frame. For example, IMU or inertial measurement unit that's used to measure the orientation of quadrotor measure quantity based on this body frame. In the other direction, GPS that's used to measure the position of quadrotor measure quantity based on this inertial frame. So in order to project quantity between the two frames, we used coordinate frame transformation. Coordinate frame transformation is used to transfer quantity between the two reference frames. So to avoid non-unity geometric similarity and conditional cost that comes with irregular approach, we use quaternion approach for coordinate transformation. So this is a rotation matrix which uses to project body frame quantities position quantities from body frame into inertial frame. This is a rate transformation matrix that uses to project body frame rates to inertial frame rates. So, by using this coordinate transformation, we apply Newton's law to derive quadrature dynamic model. To derive rotational dynamics, we implement Newton's second law for rotational motion. So, by implementing or by manipulating this equation, we get rotational dynamics of quadrature. Similarly, by applying similar approach, here we determine the rotational dynamics equation, right? So, in order to precisely model quadrature dynamics, we consider aerodynamic ground effect. Aerodynamic ground effect is it is aerodynamic phenomena that the ground pushes the quadrature up when the propeller approaches to the ground surface. As you can see from the figure, when the quadrature approaches to the ground surface, some portion of Earth goes back from the Earth's surface. This increases the thrust force generated by propeller. So this ground effect experimentally obtained as this equation. When the altitude increases, this ground effect decreases. They have inverse relation, right? So by including this ground effect, we have the modified thrust equation, right? So by including this ground effect, here we have a governing equation for quadratic dynamics, right? These equations are a control allocation equation, which relate control effects with propeller speed. One problem that comes with using quaternion approach for orientation is visualization problem. So, in order to solve this visualization problem, we use this equation that convert quaternion into Euler approach because we all are familiar with these Euler approaches. So when we come to the controller design part, quadrature is it is undirected dynamics. So in order to solve this, we implement a nested control approach. Nested control approach, after or position controller generate desired pattern for active controller, then active controller take control action based on this generated desired pattern. So in order to control effectively the transition dynamic motion of quadrature, we implement a virtual controllers. So, virtual controllers are innate forces which drive quadrature along XYZ direction. So, to define these virtual controllers, we take the phenomena of if there is no external force acting on the quadrature, we only have two forces. Those are the forces generated by propeller and gravitational force. By manipulating this equation, we obtain the virtual control input equation. By substituting this virtual control input into the quadrature dynamics, we obtain the new governing location, transition motion, governing location of transition motion of quadrotor, right? By doing this, okay, these equations are comparison equation that used to determine desired pattern and total response from control effects which obtained from position controller block. This is the overall architecture. Okay.
You are five.
Yes, sir.
Minutes. One in mind.
Okay. Okay, Doctor. Thank you. This is the overall architecture of our proposed control architecture, right? This is a position controller block. In order to design a position controller, we follow the following three steps. The first step is designing conventional model reference adaptive control. The second step is training neural network by obtaining input-output data of adaptation block. In the third step, we implement online learning algorithm to implement the neural network parameter in real time. This is attribute control architecture. In this architecture, we have two neural networks. The first neural network is used for system identification. The second neural network take control action based on the identified model. These are the simple locations that used to determine the height of quadrotor with a given resolution parameters that built in quadrotor dynamics, right? This is a training, neural network training, performance on training, validation, testing data set. This is a controller network. This is a controller performance on the training data set. As you can see from the figure, the neural network output is perfectly tracked, the reference model output, right? The last step in controller design process is implement online learning algorithm. So to implement online learning algorithm, we first implement offline learning algorithm to get initial sets of network parameter. This is algorithm that uses to apply network parameter in real time. In order to train for image analysis, we use convolutional neural network because they show a promising result in processing visual data. So by implementing transfer learning approach in this study, we train a sufficient neural network by using this dataset, which obtained from Kaggle website. This is the overall controller block that developed in MATLAB Simulink. To check the performance of quadrotor, the first trajectory is, this is the main trajectory, which is specifically designed for precision agriculture. So, as you can see from the figure, the actual trajectory perfectly track the desired one, right? In order to, this is trajectory along each direction. In order to check the controller performance, we impose some parameter variation in the system dynamics. Right? This uncertainty is considered as imaged uncertainty because they are considered in controller design process, right? As you can see from the figure, in the case of event, when the system affected by much uncertainty, the controller doesn't boost its performance. As you can see from the figure, the actual trajectory perfectly track the desired one, right? The third scenario is by imposing or by injecting gusty wind into the system as an matched uncertainty. Some comparison is also made right here. As you can see from the figure, this response is a conventional model reference adaptive control response, right? This is offline neural network based mirror response. This is the green one. When you the third one is the blue one is it is online learning based miracle approach, right? In the case of conventional case, the error is big when compared with the other one. In the case of offline learning, the error is almost constant because there's no online algorithm implemented very. In the case of online learning algorithm, the error is continuously adjusted when the error is within up to the error is within the predefined range, right? So this figure shows that this online learning algorithm enhance the controller performance, right? When we come to the image analysis part, we obtain 97.8 training accuracy. As I said before, the primary goal of this research state is developing high performance controller, right? To make our research application specific, we include image analysis part. So, depending on these results, we make some conclusion remarks right here. The first conclusion is, as you can see from the figure, based on the figure, based on the result, the proposed controller has tolerating much uncertainty. This shows the good performance of the design controller. The second one is The required control efforts are minimal and small. This prove functional safety and economical use of control system. The third one is from image analysis, the retained CNN model or exhibition CNN model can be used to detect yellow stress and its severity level. So the future work will be hardware implementation. Thank you for patience. This was about today's presentation. Thank you, Doctor.
Okay, thank you, Murugan, for completing your presentation within the given time. And the floor is open for question and suggestions from the audience. Any question? Okay. So if the audience has now have no question, Mulukan, 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 are you hearing?
Okay. No, I'm hearing.
Okay.
Okay.
So
You can go.
what is your contribution in the architecture or post architecture that you presented to us?
Okay. Okay. As I said before, my approach is the novel approach. Alright? There is no.
How can we be sure?
Okay. Yeah. You can refer some literatures, right?
So you have to
Is the
refer
best
to the
content?
literature and convince us that it is new. I
You
didn't
can
see that.
contact me. Those are my advisors, right? Dr. Lusa
Alright.
and Dr. Daraji. Okay.
Okay.
And I explained over here, right? These are my contribution. And this approach is novel approach. Okay.
So entirely your architecture is new exactly.
Yeah. I'm going to publish
And
on my
did you
paper
publish or are
under
you
review.
going to publish?
My paper is under review on IEEE access.
So in your conclusion,
Okay.
you said the proposed model is promising
Yeah.
model to solve the research problem you addressed.
Mm.
How promising is promising?
Promising it is related with its performance, right? As you can see
Uh,
from this figure, our proposed approach has good performance than the other.
97?
Yeah, okay. From image analysis part, as I said before, my ultimate goal is developing high performance controller, right?
Right.
This one is the main goal. Yeah, to make my research study application specific, I just include the image analysis part for precision agriculture.
Okay, thank you, Mulukan. And now it's over. The presentation is so.
Okay.
The next
You're welcome.
presenter, I think Joshua is online. I think the first presenter because of his absence. Joshua,
Can you hear me?
are you hearing
Yeah.
me?
Yes, we can hear you.
Okay, so Joshua, as I tried to,
Please, can you hear me?
yes,
Okay.
introduced before is from, I think, UN Africa Regional Center for the Space, Science and Technology Education. And its title says Global Warming in Ghana's Major Cities based on the statistical analysis of NASA's prediction of worldwide energy resources over 3 decades. Now, Joshua, you have 50 minutes exactly to finish your presentation. Thank you for joining us.
You are welcome. I'm very happy to present this topic to you on global warming in Ghana's major cities based on statistical analysis of NASA's prediction of worldwide energy resources over 3 decades. This project won the first dissertation at the United Nations Africa Regional Center for Space Science and Technology Education in English. And we use machine learning approach to ascertain that there is actually global warming happening in some major cities in Ghana. To begin with introduction, we know that temperatures are on rising in Africa and the world. Even though Africa is not contributing much to this effect, we are experiencing more of its devastations. And that we took a step to climate actions by the SDG Goal 13. To begin the work, I had to look at some of the research that has been done in this area, especially looking at the data sets we'll be using. So that's in terms of the prediction of world energy resource data, I look at one research that used the power data for assessing solar cities in Ghana, and then they were able to create a database for informed solar radiation assessment. And my former supervisor, which is now the vice chair of the IPCC, contributed to this modeling by using the regional climate models and then global climate models to predict minimum and maximum temperature in the northern region of Ghana. Other work that have been done using machine learning approach, but not power data, is Sujan Jimire et al. From Australia, which made use of Moody's data and then artificial intelligence to predict global warming for from 2020 to 2018. So we define the problem as such that there is no, or there have not been any study to understand temperature variations in Ghana with the NASA's prediction of worldwide energy resource, hence local warming in its major cities. So we therefore show this and further by employing the machine learning models for long-term study. But the aim of my study is to verify temperature variations over 4 climatic zones in Ghana using the prediction of worldwide energy resource data. And some of the objectives that helped me to achieve this was statistical analysis, using the linear regression test and the F-test of power data, and then to compare the data with Landsat temperature profile and predict within the short term how temperature varies using power. This third objective was derived from the first and second objective because we could not compare power with the Landsat temperature profile mouse. And then the model we used from the machine learning point of view, the HD boost did everything perfectly. To begin with, this is our study area. We divided my cities, the 4 cities I'll be looking at, into 4 different climatic zones in Ghana: Accra, Kumasi, Katepachi, and Wa in the coastal zone, forest zone, transition zone, and the savannah zone. And I made use of the Power Project, which derives its data from NASA's World Climate Research Program, Global Energy and Water Cycle Experiment, Surface Radiation Budget Project, and the Global Modeling and Assimilation Office of the Goddard Earth Observing System Assimilation Model, whose original version came from the finite volume general circulation model. So the power therefore offers a valuable climate variables for this study, and the database has an advantage of being generally contiguous in time, as in it's provided on a global grid having a resolution of 0.5 degrees latitude to 0.5 degrees latitude. So this is how the data looks like, and I made use of Anaconda Navigator and then ArcGIS tools as well as GitHub. And my methodology to achieve this was to acquire data and convert it using novel format. I then did some statistical analysis. I studied the non-surface temperatures, and we compared this result and further train our XGBoost model to make good predictions for us. The first the first objectives, which is to study the statistics, we did a linear regression trend for the first city in Accra and realized that temperatures were rising at 0.0175 with a root mean square error of 0.5 degrees. That's the linear regression model explains 53% of the dependence of the years on annual temperature, and then the second city, the linear regression model did better, did less better, which provided a root mean square error of 0.45% for us, for 4.5% root mean square errors. And then we saw the root mean square error for the last city to be, the third city to be 0.08 and indicated 0.092 increase in temperature per year from reference year of 1980, which is 0 over year. And the last city, which is the Savannah zone, there was no increase in temperature at all. There was a decrease rather that's been seen. And to verify these results, I had to verify or show the um, 95% confidence interval and then the 95% prediction interval. The 95% prediction interval is an interval that we're 95% confident, 95% confidence interval is an interval that we're 95% sure that the linear regression model lies. The 95% prediction interval is an interval that we are 95% sure that any predicted year taken ahead of these years will fall under this plot. And we realized there was a spike in this region, which is 1998. And according to the National Oceanic and Atmospheric Administration, 1998 was the 10th warmest year globally, and we expect that this should happen in Kumasi as well. And this was what we saw. So, sorry for that. So, to ascertain the linear regression trend model works very well, we proposed some hypothesis, which is not hypothesis, an alternate hypothesis for the ANOVA test and then the T test, which depended on the intercept and then the slope. So the null hypothesis was that there was no significant effect in explaining the variation in the mean temperature, and the alternate hypothesis for the ANOVA test was that there's a significant effect on explaining the variation in mean temperature by the years. And then for the intercept, the null hypothesis, we propose that the mean temperature in a specific case equal to the mean temperature in a reference year, and that the alternate hypothesis, the mean temperature in a specific year, is not equal to the alternate hypothesis in the reference year. For B1, which is the slope, there is no linear relationship between the relative year and then the mean temperatures. So the results we found that show that we took from arbitrary taking value of 0.05, the ANOVA test for Accra was agreed upon, and then the T test of Accra was also agreed upon. For Kumasi, the ANOVA test was the null hypothesis. Regression has no significant effect on explaining the variation in the mean. We had to reject the null hypothesis because the p-value was greater than 0.05. Meanwhile, it was having a greater t and p-value for the t test that we did. For Kedekrachi, the null hypothesis was not so far from the 0.05, so we further agreed on the t test, which was bigger than that of Kumasi. So we further ascertained that Kedekrachi, the test city, should be experiencing global warming or a change in temperature. And then for WA, the changes remain the same as the p-values remain greater than 0.05, and its T test values are also less in all cases. And so we went ahead to do some monthly variations in temperature changes, which we didn't see much variation in Ghana's seasonal from dry season to wet season. So our wet season starts from July to October, and then our dry season starts from November to May. As we can see, there's no changes in all cases. And so we went ahead to compare the power data with the Landsat data by visualizing temperature changes with the land surface temperature map. We we realized that temperatures in Accra are actually very high, and that the effects of the linear regression trends is actually correlating with that of the Landsat. And for Kumasi, even though Kumasi was also really high, there was no much changes from 2002, from 2000 to 2016. The temperature changes do not really vary that much. And so we went to Ketekrachi and we saw the same thing happening. That 1987 appears to be more warmer in critical places compared to 2014, which was more dense or urbanized. And then there was no changes happening in the last city in the Savannah zone of Ghana, which we can see below. So we compared Landsat with temperature, with the power data, and realized that Landsat in all cases ranked Ketekrachi to be the least warmest year, and ranked Accra and Wa to be the highest warmest year. The power ranked Wa to be the least warmest year. City, sorry. So Landsat ranked Ketekrachi and Wa Landsat rank Edekashi as the least warmest city and Wa and Accra as the highest warmest city. And then Power ranked Wa in the Savannah zone as the least warmest city and then rank Accra in the coastal zone as the high or let me say the city with a high temperature variation, which is not correlating and is not true from our observation on the ground. Why is supposed to be the warmest city followed by Petekrashi or maybe Kumasi, then Accra or something like that. But these discrepancies were the things that encourage us to use the SG Boost model to do a great comparison. So before we go to the SG Boost, we propose that maybe these temperature variations could be due to population density. So we took the census data from our study period, which is 1982 to 2022, and we realized that temperatures were rather dropping in Accra, and so it didn't account for the increase in population is rather dropping in Accra, so it didn't account for the increase in temperature changes in Accra, and then Kumasi as well. Meanwhile, Karachi, which was the highest city, the least warmest city is experiencing a high population growth, so which is not correlated, and while experiencing a high population growth, is actually not experiencing any temperature changes, which is also not true. So it means that population does not depend on our current study of temperature variations in these cities. We went ahead to predict short-term how temperature varies with power data using the XG boost, and our training data we use a 1982 to 2020 for Accra, and I think that the XG boost didn't perform so well in Accra, so we had 3.582, which is not so good, and it did improve for Kumasi, which is 1.464. And in the training of Ketekrachi, it's outperforming Kumasi and Accra by giving us a prediction of 0.987. However, we constrained the training for Ketekrachi from 1982 to 2018 as to make sure that every training experiences equal less constrained. Yeah, so we constrained the time from 1982 to 2018 to make sure that the training works well without any constraint. And the last city, which is WA, actually the second best performer, predicting by the SG boost, gave us 1.34 root mean square error scores. And then the training data set was from 1982 to 2018 as well. So this was the second best performer, followed by Ketekrachi and then Accra to Kumasi. So we went ahead to now do a mid 2023 mid 2023 study of predictions and realized that WA actually is the warmest city in Ghana per the climatic zones that are in Ghana. So WA is supposed to be the warmest city, followed by Ketekrachi in the transition zone between the Savannah zone and then the forest zone, and then the Kumasi, and then Accra, which is in the coastal zone influenced by the Atlantic Ocean, and then Kumasi in the forest zone. So the exhibits actually predicted now very well what we are supposed to expect in the case of the power data and then the Landsat data. So from the feature importance, we realize that the Earth's skin temperature is having greater contributions to temperature variations. This factor was considered in framing the Paris Agreement in terms of ambitions to stay below specific levels related to pre-industrial climate. And I believe that the prospect of these have been constrained by constabilization of the carbon dioxide at concentrations around 450, 750 and 1,000 parts per million globally. So I think the conclusion you can make from this work is that by power data, only three cities are experiencing temperature variations or local warming, but at a minimum rate for the long-term study, and then population has less effect in explaining this variation. From the projection of the machine learning view of mid-2023 temperature variations, it aligns close to the real nature of each climatic zones in Ghana. So from Wa to Ketekrachi to Accra and Kumasi, in Savannah zone, in the transition zone, in the coastal zone, and in the forest zone. We expect that temperatures are at least rising in the forest zone in Accra, which is in Ghana, which is Kumasi, and then temperatures are high rising in Wa, which is in the Savannah zone. And then SG boost model we employ. And so contribution knowledge is that the long-term study of temperature variations of power for short-term predictions was done unlike other methods that use short-term prediction of in-situ data, like the Ghana Meteorological Agency, for long-term predictions. And we believe this is so they are able to do this within the short term, within the long term, using short-term study because they have huge data. Unlike us, we used 14,975 data points for 30 climatic variables to train just one single temperature variable. We believe the contribution to knowledge of this work is that we were able to use such parameters to predict in the short term, while other agencies in the world that use robust algorithms and high performance computing to predict in the long term. And that's I would recommend machine learning artificial intelligence models should be incorporated into large language models and even in situ data collectors or devices to make inferences and learn from the data being collected in the study. Another recommendation would be that the Earth's skin temperature should be considered in making temperature predictions for global warming. Thank you so much.
Thank you, Joshua, for completing your presentation within the given time. Sure. And I give the floor to the audience to raise questions if they have. Any question, comment, or suggestion on the presentation? Okay, so if the audience do not raise question, let me ask you, Joshua, one question.
Okay.
Okay, what makes this research relevant to this conference?
From the services,
I mean,